Check this out for low tech. Here I am introducing integration by parts by showing you a video of a projection of what's already on your topics page. The notes that you're going to need, or that I wrote up for chapter 8, that are going to be on, that we're going to cover on the topics page on the portal. But I just wanted to show you that integration by parts, this really cool thing that works super well for integrating, is all based off the product rule. This, my friends, is the product rule. If you have two parts, instead of saying F and G like we used to, we're going to say U and V. But that's okay, because we take the derivative, we get the first times the derivative of the second plus the second times the derivative of the first. All we need to do then is integrate everything. The integral of this derivative is just UV, and then we put an integral symbol in front of each of these. Guess what's going to happen with the dx's? So when I integrate with respect to dx, the dx's can cross out, and I'll be left with this. We're going to rearrange it, and here is your final rule down there. That's the one you need to know. And here's what you should remember. Ultraviolet voodoo. Look at what's on the bottom. In fact, look on my forehead. Ultraviolet voodoo projected on my skull. What that really stands for is ultraviolet voodoo. So that's a really dumb way of remembering the integral by parts. And I also wanted to throw in the fact that, this is really good when you have two, not four, but two different types of equations. Let me give you some examples. Here's 4 examples where you have 2 different types of functions inside an integral. You have an algebraic x and you have an exponential. Or you have an exponential e and you have a sine or a trig. You have an algebraic and a logarithmic, or an algebraic and a square root, which is still kind of algebraic, but they're 2 different types of functions. So this is where, not only am I going to show you how to do this, but this is where it really helps to remember the phrase liate, which is actually also on your notes. Remember, topic section, chapter 8 on the portal. Liate stands for logarithmic equations, inverse trig, algebraic trig, and exponential. If you go in that order, if you make the first type of function that you encounter equal to u and the second equal to dv, you're going to be in good shape. We'll talk about how you can sometimes do this many times and a couple other examples. Just remember, hey garçon, can I get another liate here? And you'll be well on your way to success. So don't forget, integration by parts. The integral of u times dv is equal to ultraviolet voodoo. Here's how you do that voodoo so well, and let's use it. Example number 1 up top here. As we look at it, we have an algebraic and an exponential equation. As you go down the quick little list here, liate. In this first example, do we have any logarithms? No, skip it. Inverse trig? Nope, don't think so. Algebraic? Ding, 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 ding. We have a winner. So here's what we're going to do. We're going to let, for this first example, u equal the algebraic part. So we write that down for example 1, and then we let dv, the second part of this, equal everything else. U is the first the first type of equation that comes up on liate. dv will be what's left. And then to make sure that we can make this work, we need to find what is the derivative of u and what is v itself. To do that, we're going to take the derivative of u and we're going to integrate dv. It's going to look like this. Now I know as we're doing this, when we integrate dv, 1, don't forget about the chain rule. That's going to be 1/3 times e to the 3x. 2, don't worry about that plus c. It's going to come in later. But now we know what u, du, v, and dv are, and now we can rewrite the entire equation for example 1. In rewriting it, we have u times v minus v times du. And now we will have to integrate a second time, but this integral looks entirely plausible. In fact, maybe even likely. In fact, we've even kind of done it earlier, so really, we're going to roll with this and come up with an answer. And there you have it. That's integration by parts.